Hello everyone, this is Minicoder coming back to you with the last and final tutorial on Programming Basics 101, or Basic Programming 101 actually the series is called. So, we've gone over quite a few things since we started. The last thing we talked about was statements, with if statements, else statements, do whiles, stuff like that. I know I went over that a little quick, so if anybody needs some advanced or a part 2 of that, please let me know and I'll add that. Today we will be going over null values and try catches. And I thought that was probably a good combination because null values and try catches both are kind of used very often, pretty often, because a lot of times null references are where you have an exception, and what a try catch does is it allows you to try some block of code, whatever that may be, and if a what they call an unhandled exception, which means neither the developer nor .NET was expecting something to happen, it will throw this exception and let you either handle it, or it might blow up the app. So sometimes when you see an app just completely close or throw a weird error with those gray boxes and the big red X's, those usually are some kind of exception that the developer or the .NET framework was not expecting to happen, and somebody either did catch it and threw that error to the user, which is usually a bad user experience, or they they didn't have a try catch there at all, which is fine because you don't try catches are very expensive, so you don't want to always use them. You don't want to use them everywhere. So, excuse me, what I've started doing now, or what I had started doing here, was I set up a few things set up for failure. Um, what I did was I extended this if statement method that we use to uh, have a string value inside of it. And actually, what I'm going to do, I didn't do before, is just so we see it. Oops, let's do this. So there are some escape characters, /R and /N, which is basically a carriage return. So we're going to do a carriage return, which means it will make a new line no matter what calls it, and then we'll have it do return, or not return, string val equals plus string val. And we'll do this in both cases. Oops. Just so we know that it always comes back. It should never hit this at this point, because 3 plus 5... actually, I'm sorry. It should always hit this one at this point, because we're not changing the numbers up here. So actually, this is the one that matters. So let's just do /R/N, so that we know we're going to hit it, or that we will see it on a new line. Okay, so what I'm going to do first is I'm going to show you what's going to happen. So there's a string val we added to this method that some developer used, right? And we're utilizing their method. We decided, well, you know what, I don't actually need to do anything with that, and as far as I know of, I don't need to provide it to validate whether or not a number and another number equals 5. So I assume that it's an optional variable, which is a bad assumption, but it happens. And so we're going to return a null instead of an empty string, or we're going to pass in a null, I'm sorry. And right here we have this, we're taking that string value that's passed in and doing a .toString to it. Now I'm going to let it run first, and then I'll explain a little more into what toString is and what this is all happening here. So first thing you're going to see here is this null exception. What that means is exactly what it says, null reference exception. It means you were trying to reference something that was of value null. Now, the difference between an empty string and a null, or anything for that matter, is that an empty string actually has memory assigned to it of some sort. Whether it's big enough or not big enough, that's a whole different story. But just the fact that there's memory there for the runtime compiler to do something with, or the program to do something with, is available. A null value means that you have a variable that's there to be used later, and the compiler, the pre-compiler, not the runtime compiler, but the pre-compiler is making an assumption that you are going to use it at a later date. Now, there are some times that it tries to be a little smart for you, like if you hover over, well, I'll have to stop it, but this little green squiggly is letting you know that, hey, you have this value here, but you're not using it anywhere, so you can get rid of it. There are other instances where I'll tell you, hey, you have this variable, but you never assigned. It's been completely unassigned. So it'll try to help you along, but it won't catch everything. And this is a perfect instance of that. Is that it's assuming that you're going to do something with it, and we didn't. So if we click View Details, it's going to tell us this wonderful message, which I love so much I called my blog objectreferencehell.com, because everybody does not everybody hates object references exceptions. So what this means is that you try to again, like I said, you're trying to reference an object, and a string is an object that has not been set to anything. It has not been sent to string. Is not to an empty string. It hasn't been set to an array of characters, which is what a string is. It hasn't been set to anything. Um, so, oh, and the other thing in the view details, which I'll show you in the try catch, you also get, is you'll see the stack trace here. So now if we open up this stack trace, actually, you know what? This is really hard to read, so I'm going to show it to you actually when we do this, the catch, the try catch. So there you go. So there's your problem. So now if we hit F12 here, and this is for any .NET class inside of the .NET library or framework, you can see all the properties and methods that string has available to it, and there's a lot. You'll also notice that some of them are with the same name, but they have a different signature. Those are what are called overloads as opposed to overrides. So what I made here, just as an example, I know this is going a little off course here, but make name with the same name, but they have the different signature, because this one actually doesn't pass anything and assumes the name that it's going to return. This one is asking for the name, and then we'll return that name. Not that it does much, but just to make the point across. So you can do overloading on your own classes. And what it looks like when you do something like that, if you do cat c equals new cat, okay, and we do c dot, you'll see just like the other one, everything that you inherit from animal and that you made in the cat class. And if we open and close parentheses, you'll see that there's a one and a one of two here. That's because there's two methods by the same name that have options. This is very helpful, and I'll go over in other episodes, in the more advanced probably, since this is the last one in this series. However, I just want to show you that just like string, .NET makes pretty much everything they do possible in your stuff. So you'll notice this is very similar setup. It's a lot more, but there is nothing, just like up here too, by the way. You can see that they did class, string, and these are what are known as interfaces, which I didn't really go over yet. I think that's a little more advanced, but again, they are inheriting from these, which could be abstract classes and other classes. The only keyword you haven't seen as of yet here is sealed, and that means that nobody can inherit, can create, can add to, can instantiate, nothing. It's sealed so that nobody outside of this assembly can even look at it or touch it. Well, not look at it, but can touch it, as in add stuff to it, override it. Nobody can do that. So one of the options here that I opened up here is toString. Now you can't actually see the code, but they'll give you comments as to what it does, and it's going to tell you it returns the current string. So it's not like I made up that toString. It's hanging off of the string object. or the string, yeah, the string object slash string class, however you want to look at it. So what can we do about this? Well, as a developer, we could handle it with an if statement and check to see whether it's null. The simplest way, without going into using the string class, is to look for string val is equal to null, or is not, actually in this case it would be is not equal to null. Then we'd want to do this, okay? And actually this would still fail. If it wasn't equal to 5, this would still fail. So what we could do is if string is not equal to null, do that. Otherwise, we would do string val is equal to nothing was provided. Okay, that way it's not null and we can at least move on with our day. And it will be set, actually it will be set here. So when we run this, now it won't fail, and string value equals nothing was provided here because it fell through. Notice that it was null, didn't run the dot string, and we actually did assign it something this time. Now, with that in mind, given that this wasn't what was done, as the developer using the tool, as soon as we see something like that, and you're going to want to use try catches a lot in something like a database call, because you want to be able to handle should the database not be available. That's a biggie. So a try catch is very easy. It's literally try and catch. And I'm going to do the simplest version of a try catch here. There's many ways you can specify exactly which exception you're looking for, have change catches that do things based on what kind of exception is caught. But for right now, I'm just going to do a basic try catch, and then I'll do a console dot write line something bad happened here. Okay, now I'm going to put a breakpoint, right? Actually, you know what? Before we put a breakpoint, let's just watch it happen. So what should happen, we commented all the other methods out, is we did the try, it's going to blow up here, and it's going to do what's called the bubbling effect. So it'll bubble up from this where it explodes right here, and it'll bubble up to the caller that called it, and it'll keep trying to bubble up until either it reaches the top application and just completely poops itself, like the application just closes, or the first try it finds with a catch, it'll try and catch, and you can either handle it, or you can just swallow it and move on, depending on what you're expecting or not expecting to see. Most of the time you want it in here, you would log what happened, and then move on, or tell the user some other more useful information of, please grab the logs and contact support. Something like you would write that out, but log it first. And I'll show you what you would log in a second. So let's start this. So there you go. You see something bad happened here, end of program. That's it. So it didn't blow up, but it showed our quote-unquote user-friendly message instead of blowing up, right? So now, the best way to debug this is to put a breakpoint on the catch right before it does anything. And you see how I added this EX here? Even though it's declared and never used, exception went inside and it created it, and you'll notice that it made a new version of it. And you'll notice that object reference not set to an instance is the same, and you'll notice the stack trace I was showing you before. Now if you hit this magnifying glass, this is a little easier to consume and read. It goes from the bottom to the top. So the first thing it'll tell you is where it originally happened. It happened within the program.css class on line 44 is where the blowup actually happened. If you look here, sure enough, the .to string is what blew up on line 44. And then where it originated from is line 18. And like I said, if it bubbles up and bubbles up, this stack trace can get huge. But this will show you that line 18, hey, this is where the world all went to shit. And you'll see right here, line 18, and that's exactly where we passed in the null. and we continue, and there you go. Alright, so that's your introduction to nulls and try-catches. Again, nulls are, unlike anything else, they're something where you, and it's in all languages, there's null, in Objective-C, Objective-C it's called nil. I think there's some other languages that use nil also. They're all the same. It just means that there's no memory assigned to it yet, so the object was not created, so you can't hang off of its methods. In fact, actually, a good example real quick, we're at 15 minutes, but I think this is well worth showing, is instead of this inside of the try catch, let's do one of our objects. So let's do cat C, and we won't define it yet, right? And then we do C dot age, right? Now normally that would just return us the age. It actually threw a complete error and said, hey, you're using an unassigned local variable. Now, although it's being cute, because it knows you haven't assigned anything yet, which I'm smirking, I know you can't see me right now, but I should be able to tell it null. Interesting. I didn't think that would work. That would happen. Only assignment call. Oh, that's something else. Okay. So int age is equal. It's just telling you that you're trying to do something with the age that didn't. You're trying to call age and get it, but you're not assigning it to anything. So that's a compiler error. So now we set cat to null, so there is no memory assigned to it yet. And watch what happens. It's going to blow up because you're trying to get the age of something that has no memory yet. And there you go. You got an exception. Object reference not set to an instance of an object. So and to fix this, all you do is you new it up, so you instantiate it, and there you go. And you won't hit the catch. There you go. See? I don't think we ever assigned the age, so it's going to be 0 because integers are one of the ones that can't be null. So they default right away to null. Or I'm sorry, they default right away to a value. Sorry, I got a phone call, so it's hard to do two things at once here. So just by that alone, tells you know, that a lot of them, they default to something. So you don't want to use null too often. So, int defaults to 0, decimal defaults to 0.0, bool defaults to false. So there's a lot, but objects that we create especially do not default to anything. You have to assign it something, and same thing with string. So that concludes all of our tutorials. And hopefully everything's been very informative. Like I always say, please, if you enjoy my video, subscribe, and you'll get all my latest videos. And thumbs up and thumbs down is always appreciated. Just if you give me a thumbs down, if you can let me know what you didn't like, what I could do better next time, I'd appreciate it. I want to make these as good for everybody as possible. I know how difficult it can be to learn programming when you're first starting, and I like to make sure that everybody gets what they need. Alright, so this is Mini Coder signing out, a basic programming 101. Next time you speak to me, it'll be more on advanced programming. Alright, thank you very much. Have a great afternoon.